Okay, welcome to EKG Basics. This is class number 2. We're going to go over some stuff today to complete one more class over EKG Basics. Give me 1 second. So I need to... All right. We're going to take on what we left before. This is a Tobin's triangle. Remember that we went over the lead placement and then we obtained the 6 leads on this screen right here. Lead 1 across the horizon from the right to the left shoulder. And then we have lead 2, lead 3, which are bipolar leads, 1, 2, and 3. And then we have the unipolar leads, ABR, ABL, and ABF. Remember the way the arrow is looking at, so from where you're looking at to the end point. So we're looking from the negative side on the bipolar leads, and on the precordial, the unipolar leads, we're looking from the heart out to the sides. Okay, so when we add the precordial leads to this is more or less what it looks like. By the way, this is an image from Cables and Sensors. If you want to go check that page, I put a link on the image. So if you want to check it out, it's really amazing. So I like this image because we can actually see the heart and where the leads are actually positioned in relationship to the heart. So we can see here bipolar leads because we're going to see lead 1 across horizontally, lead 2 coming from the right to the left, right here to the left. So lead 1, lead 2 coming from the right shoulder to the left leg, and then lead 3 coming from the left to the south, let's put it that way. And then we have the unipolar leads, ABR, ABL, and ABF. We can see them here. And then in this image, we also have the precordial leads, V1 through V6. And that's the way they look at the heart. So to make a little bit more sense, depending on the position that you are, is the area of the heart that we're going to be looking at. It's not that you can see everything from one side. It's a perspective. If you're in front of a tree, you can see the tree from one side. If somebody else at 90 degrees, they were going to be able to see the same tree, but a different perspective, where the profile is going to be different. And then same if somebody's behind the tree. We're all going to be looking at the different areas. So this is more or less the concept of the leads, the 12 leads that are going to give us a different view from different areas. So this EKG, this is what an EKG strip looks like. And if you can see here, we are looking at, 1 second, I'm trying to get my image here. We're going to see here, there you go. So we see here lead 1, lead 2, lead 3, and then we have ABR, ABL, ABF, and then we have the precordial leads, V1, V2. I'm going to circle them all just to make sure that we cover B4, B5, and B6. That means that all the information that we gather from all areas of the heart is going to be represented in a 12-lead EKG like this. So it means that this is a 6-second strip. So that means we only took 6 seconds total of the patient. So here, the lead 1 is only going to be from here to here. Lead 2 is from here to here. ABR is going to be from here to here. So it's just like chunks, like they're each reporting what they're looking at, if that makes sense. Okay, so I'm going to remove this one so it's kind of a little bit clearer. But because when we are interpreting an EKG, we are going to focus in certain areas, depending if we have a lesion or a specific area that we want to look at. But when we are just doing a regular EKG, we are going to pick one lead just so we can get more information. Because as you can see here on this area, I have very little information. So in this case, and in most cases, we're going to pick lead 2 because lead 2 is going to give us a lot of information. It's going to have a big view of the heart. If you remember, it's from the right shoulder to the left leg. So that's going to give us a whole view of the heart. It's looking entirely, it has a really good perspective. So lead 2, in most cases, is going to be baseline to obtain the 6 seconds. So if you take a look at the bottom lead, it's lead 2, and it's a whole 6 seconds here. So this is what we're going to be using to count the heart rate or to see any morphology changes or whatnot. Another thing to look into an EKG strip, there's a couple of things. We need to look at the speed, has to be 25 millimeters per second. And it also has to have a voltage of 1. So this is 2 large squares. So 1 square, 2 squares. So your voltage has to show like this. That means your machine is well calibrated and it's at a regular speed. If it's faster, then your EKG is going to look different. It still gets the information, but it's just faster or slower. And if your voltage is smaller, your image is going to be, it's like when you're zooming and going in or out. Okay, so let me just, I'm going to remove some of the my beautiful images here. There you go. So when we look at an EKG, we see some morphology, and we typically see EKG and we think at these deflections, and they pretty much look the same when we don't know how to read EKG. But this is going to give us all the information, what is happening in the heart. It is the report of the view of certain areas of the heart. So that is also super important. Remember that we talk about, for example, lead 1 goes from shoulder right shoulder to the left shoulder. So the heart is going to be, this lead is going to oversee the heart in that specific side from the right to the left. So it's going to report how it's looking from the right to the left. And this is what's going to report. Like, by the way, on this case, you can see like a lot of wiggle, it's stiff here. We're going to call this artifacts. That could be touching something, or there's no movement on this patient. You can see it's a steady line, but it could be something interfering with the electrical signal. But it's okay. We can use, if we're going to determine something else, we can use other leads. Okay. So just let me erase all this. There you go. Now, when we look at an EKG, what are we looking at? It's like, yes, it looks like a lot of something when we don't know what it means. Okay, so for that, I have this image so we can describe a little bit of what's happening. We already know about the action potential, which was the beginning of the course, so you can understand how the current is transferring from in the myocardial cells. Okay, so again, we're more likely we're going to work with lead 2. When the heart releases the energy or starts or activates, the SA node fires and then transfer the electrical conduction all the way to the ventricles to provoke that contraction. So how do we know when are these things happening? Okay, in our environment, P is going to represent the depolarization of the atria. So when we look at this deflection here, the little curve is going to be a positive deflection. I think we have to start by talking about the isometric line. The isometric or baseline will be this line where it's 0. And then if the deflection is above the line, it's going to be positive. And if the deflection is below the line, then it's going to be negative. Okay, so P is going to represent the depolarization of the atria. That means the SA node fires to the through the both atria, right and left, and then it goes to the AV node. But P represents the depolarization of the atria. The first part of the P wave is the right atrium, and then left atrium on the second part of the P wave. It has to be upright. It has to look Nice. So we can determine that it's something normal. When we are trying to read EKGs, we need to know what normal is to identify what is not. Now we can see the conduction goes back to isometric line. That means the speed slowed down. This is a pause between the SA node and the AV node. It gives a chance, and it actually, the speed reduces a little bit, and that's the pause. So we want to see this pause between the atria and the ventricle because the electrical conduction needs to readjust. So we call this section between the end of the P and the beginning of the QRS. This is the pause on the AV node. And it's going to be called PR segment, which we have. I have the names of the sections on the next slide. So let's just not stop for that right now. So let's just look at the deflections and what they mean. After the little rest of the AV node, we do have a little deflection here where the bundle of His starts to fire. And then the QRS, which is the contraction of both ventricles. That's why we have so much information on this deflection, which is between positive and negative, just the way it is in the heart, the way the electrical conduction goes. So after the conduction goes through the bundle of His, it separates into right and left bundle branches, and then to Purkinje fibers to finally all together help contract the ventricles. So that's what the QRS represents. If you can see QRS and together form the QRS complex, which is the depolarization of the ventricles. And then moving a little bit forward, we are going to see another wave. This one is not so U, but more like a mountain, and that's going to be called T wave. And this one represents the repolarization of the ventricle. As you remember, in the action potential, the cells need to rest and get ready for the next conduction. Now, we can see here QRS is depolarization of the ventricle, T is a repolarization of the ventricle. So what happens to the atria? Well, the atria depolarizes here, and more or less around here, the atria repolarizes. But because of the voltage of the atria is way smaller than the ventricular for the voltage, then the ventricle overpowers the voltage of the repolarization of the atria. It's like if I have a football player in front of me and you are in front of the football player, you won't be able to see me because I'm smaller, I'm shorter. So it is there, the repolarization of the atria does occur somewhere around here, and then is ready for the next beat. And then we have some space before the next beat. So all this together is one beat. So every time the heart fires from the SA node all the way to the Purkinje fibers, that's one whole entire beat. In a normal rate for a heartbeat is between 60 and 100. If it's less than 60, we're going to call it bradycardia. If it's over 100, we're going to call it, yes, tachycardia. Okay. Now, on the next image, I do have the sections or the measurements for the beats. The name, we need, specifically when we're working like an EP, we need to know all this information because we need to be very specific. What we can add here is some information that I need you to know. The PR interval, I have it here at 0.22. For our class is going to be 0.20. So P wave is the depolarization of the atria, as we said before, right? The depolarization of the atria, and then the transfer of electricity or the conduction to the AV node. This together should measure between 0.12 and 0.2. And we're going to see how do we measure that, because we haven't talked about this, and this is in seconds. Now, the QRS is extremely important that it is always under 0.12. That speaks of a very healthy ventricle. or ventricles, because both ventricles are represented here. And then we have some other information like the J point. That's important to know. The ST segment is extremely important, especially when we are trying to see, or when we see STEMIs or ST elevation myocardial infarctions. That's what it stands for. STEMI stands for. We're also going to have information about a segment or an interval. So we have two different ways to locate different areas. If it's a straight line, for example, here through here, in which is just isometric line again, there's no deflections, positive or negative, that is going to be called segment. But say in the same case, I get the beginning of the P to the beginning of the QRS, I'm going to have a positive deflection of the atria here, right, on P. And therefore, this one is going to be called PR interval. The way I like to remember if there's an interval or a segment is on the interval, there's something internal, something that disrupts the isometric line. So for example, here on the ST segment, right, it's a straight line. Well, it's supposed to be a straight line here. But if I were to add the T, including the T, then it'll be the ST interval. And then, I don't know why here it's a segment, it should be interval here. Important information, QRS less than 0.12 and PR interval less than 0.20. Okay, so why is it important that we know EKGs? What is this telling us? Well, I guess I need to clear all this. What is it important? What do I need an EKG for? What is it telling me? Remember that we said that the electrodes, the leads, are sending information. They're sending the report from different views. Okay, so each one of these, I want you to remember this table here, leads 1, 2, 3 on this side, the augmented voltage here, and then the precordial leads on this side. Okay, so let's take a look at the next image that I want to show you here. Okay, lead views. This is super, super important. And if you are taking your RCIS, this is going to be on your test. The next two slides are going to be on your test. You have to know your location. It's a map. You need to know the map of the heart, and you need to know what arteries are in which area. It's like we have a grid of the city and we need to locate these places, right? So if we look at this here, look, we have bipolar leads, unipolar leads, and then we have the precordial leads on this side. Okay, that's great. But why is it important? Okay. Lead 1 is looking at the heart from the right to the left. Therefore, it does have image of the lateral side of the heart. So it's looking at it like from a side, because this look is sweeping the view going to the left. This is super important. And in this image, laterals are marked in green. So it kind of starts making sense, because if there is a lesion on the lateral side of the heart, I'm going to go back to my EKG and I'm going to look at lead 1 and then ABL and all the leads that are looking at the heart laterally. Okay. And then leads 2, 3, and ABF are going to look at the inferior part of the heart, or apex. The apex, the very bottom of the heart, is called the apex, while the top is called the base. I know it's confusing because the base typically is at the bottom, but in the heart, the lower part, the inferior part of the heart, is called the apex, or inferior part. ABR, it does not give us a lot of information because there's not much to see on that side. So it has its function for other stuff, but let's move forward. On the precordial leads, remember, we're going to see the heart on a horizontal view. So therefore, V1 and V2 are going to look straight at the septum, because those leads are on each side of the septum of this sternum. I forgot the word. On the sides of the sternum. So they have a prime view of the septum, which, if you remember, when we first saw the electrical conduction of the heart, the right and left bundle branches go through the septum to depolarize the ventricle. So V1 and V2 are going to take a look at that. V3 and V4 are really anterior. So they're going to give me information right in the center, and the center part of the heart. Well, it's not the center of the heart because the heart is a little tilted, but they will be able to see anteriorly at that heart. And then V5 and V6 are going to be, they're on the other side. Remember, V5 and V6 are on the axillary line, fifth intercostal space, so they're more on the left side of the heart. So that's on the lateral side of the heart. Why is this important? Because when I see patients, or when we receive patients with a STEMI, we can more or less see what is happening. We can have an idea, how do we need to action? So this is important. So on the next image, which is by geekymedics.com, they provided this information, and it's a summary of everything that we've been talking about. And this image is also adding the coronaries, which is super important for us to know, because we are going to be able to notice where the STEMI is happening. Where is the blockage in the whole entire heart? Instead of, we can always investigate. We always need to do, investigate right and left coronaries, but this is going to give us a very good idea of what is happening. So when we look about the inferior leads, let's take a look at here. Inferior leads is going to be lead 2, lead 3, and ABF. So if I go to this image, inferior is going to be 2, 3, and ABF, because remember, they all are looking at that apex. So they are going to be able to see 90% of the RCA and a little bit of the circumflex, because remember, it wraps around the heart. So we can see a little bit of that circ. Now the lateral, let's take a look at the lateral one. So it's lead 1, because remember that lead is looking at the left side. ABL, it's also on the left side. And B5 and B6 have a prime view of that side as well. So therefore, they're going to be looking at the circ mostly. The very distal part of the LAD, and a little bit of the right coronary of the RCA, depending on how that RCA is on every patient. And you have to remember that every patient is different. They all have different anatomies. The anterior part, V3 and V4, they're going to give us a beautiful image or information about LAD, because if you remember, LAD is right in that center of the heart, facing forward. And the septal is going to be giving us a little bit of the LAD, just the proximal area, because this is very V1 and V2 are looking at the septum. So just that peak of the LAD. So this is super important. Please study that. This is critical for us to know all this information. It's not only for your test, it's for your knowledge and to be able to recognize STEMIs when your patients come in for service into the cath lab. Okay, see you soon.